Okay, so far. So we started off with factoring that was called GCF. Okay, and that was like if we had 10x plus 5. Okay, we could pull out a 5 and we'd be left with 2x plus 1. Okay, that was GCF. You pulled out the greatest common factor. And then we moved on to when a equals 1. Okay, when a equals 1. And that was like you drew 2 parentheses. We said x and x, and we found a list of a number. Okay, those were the fairly easy ones. Okay. And then we moved on to, which is what we've been doing the last couple days, is when a does not equal 1. Okay, and that's that guess and check method. Okay, and you have to check the outer and the inner and see if they work. Okay, that's the hardest of the 3 factoring, is the a does not equal 1. Okay, well, sometimes there are things that they're called special products. Okay, so that's like special cases of factoring, and they're just different from what you normally would see. Okay, however, because we've been doing the hard ones and now we're kind of go back to easy ones, today will feel pretty easy, hopefully, and it'll go pretty fast. Okay, now the one thing we really are going to touch on today, and we already have, is the quadratic form. Okay, it goes ax squared plus bx plus c. Okay, and I must not have did a good job explaining it last period, because this is I don't get it. Okay, so see the x squared? Yes? Okay, if there's anytime you see an a squared, x squared, or whatever, and there's no number in front of it, it's a 1. Okay? The bx, okay, whatever has just an x, only one of them, and no like little power with it, is going to be your b piece. Okay? Your c is going to be always just the number with no letters. So if we look at this, that's a, which is what? What's a here? 1. This is b, negative 14. And c is 49. Okay? Look at number 3. What is my a? Huh? What's my a? Look at 3. What's my a? 1. What's my b? Negative 4. C? 4. Look at 4. What's my a? 1. B? 4. C? Look at 5. What's my a? B? C? Look at 1. What is my a? B? There is no B. Okay, if there is no B, how can you guys tell that there is no B? Yeah, we're looking for one that has just an A, okay? And there isn't one up there, okay? So when there is no B, it's a 0. C, see how C is just a number? C is 9, negative 9, okay? Look at 6. What is A? B. It's 0, okay? C, negative 16, okay? So when we're going through these, okay, if there's no number there, it's a 0. No. Okay, so for instance, if it looked like this, a squared plus 2a, where's the c on that? There isn't, so what is it? 0. Okay, so if there's no number in that spot, it's a 0. Okay, so a is 1, right? Would you agree? A is 1. So that's this easy type of factoring. So you're going to draw your 2 parentheses, and we're going to fill in A and A. We're going to make a list of what number? 9, right? What are some factors of 9? 1, 9, 3, 3. I'm trying to get something to equal what? 0, okay? So remember, we're trying to add or subtract to get us that middle term. So like if you look at this one, we're doing a list of 49, and we're trying to get something to add or subtract to give me a 14. Okay, so what's going to add or subtract to give me a 0? What numbers am I going to use? 3 and 3. This is saying. So, I am, and I would prefer they don't come right now. They can come in like 10 minutes. Thanks. Okay, so we're trying to get something, so it's gonna be 3 and 3, and how do I get a 0 with that? Yeah, you can either do plus minus or minus plus, okay? But I need one negative and one positive, okay? So the order does not really matter. You can do plus then minus or minus then plus. It is totally fine, okay? And this one is done. Okay, look at 3. I'm gonna draw my parentheses, and I'm gonna say R and R. I'm making a list of what number? 4. What are some factors of 4? 1 and 4, 2 and 2. I'm trying to get something to equal what? 4. So what am I gonna use? 2 and 2, and I need a negative 4. Make them both negative, okay? And here's where we're gonna stop and talk for a second. Okay, so, don't write this down, but what is x squared? What does that really mean? Because this problem's not finished, just by the way. What does x squared really mean? There's a 1 in front of it. What does x squared really mean? What's something squared? Or something cubed? Okay, so squared means times itself 2 times. Okay, cubed means times itself 3 times. So x squared really means x times x, right? Do you agree? X cubed means x times x times x. X to the 4th means x times x times x times x. Okay, if you have, so like this, see how there's exactly 2 of them and they're 100% exactly the same? This, they're a little bit different. What's different? They're not exactly the same. What does it matter with them? One's a plus, one's a minus. These are both the same exact r minus 2 and r minus 2. So this can be rewritten as r minus 2 squared, which is how it should be written, okay? If there was 3 of those, r minus 2, r minus 2, r minus 2, what would yours look like? R minus 2 to the 3rd power. Okay, if there was 4 of those parentheses, it would be to the 4th power. Okay, if there was 5, it'd be to the 5th power. This is what your answer should look like, okay? We don't leave it like that. Okay, 5, you're going to draw your 2 parentheses, and we're going to say x and x. Okay, we need a list for 81. Don't all shout them out at once.
181.
Good.
21 and 7. Oh my goodness. 3 and 27.
You good?
No, apparently not.
3 and 21, what else? Nine and 9. Okay. I need something to give me an 18. 9 and 9. I need a positive 18. Yeah, you're going to say plus plus. Are these exactly the same? So what should our answer look like? Perfect. So it should be x plus 9 to the 2nd power. Okay, before we go any further, I want you to look at the 3 problems we have done. What do you notice about them? Look at the 3 problems we have done. What do you notice about them? They're all the same exact same number. So our first one, it was 3 and 3. The signs might be different, but they were 3 and 3. Our second one was what? 2 and 2. Our third one was what? 9 and 9. These are called special products because they're special, quote unquote, okay, because they're using the same number every single time. So use your brain and think when we're making our list of numbers, what 2 numbers are going to be exactly the same that I can use, okay? Some of these you hopefully don't even need to make the list for, okay? So if we look at 7, I'm drawing my parentheses and I'm saying M and M. I need a list of 64 and or 2 numbers that are exactly the same that are going to add or subtract to give me what? 0. What 2 numbers are those? 8 and 8. Okay, so you need to think about what 2 of the same numbers gives me 64. So 2 times 2, that's 4. It's not going to work. 5 times 5 is 25. It's not going to work. Okay, 6 times 6 is 36. So it's got to be 8 and 8. And I need a 0. So how can I make that happen? Plus minus. Hey, did we write this as the squared? No, why not? They're different. The signs are different, okay? So this cannot be the squared one. Okay? Okay, 9. We're going to say B and B. And my number is a what? 1. What are some factors of 1? 1 and 1. Okay, so this one's pretty easy. I need a what? I'm trying to get to a 0, so how can I make it happen? Plus minus. Okay, 11. Draw your parentheses, we're saying X and X. What is my number I'm working with? Well, it is going to be 8, but it's 64. Okay, and so it's got to be 8 and 8, and I'm trying to get to what? Negative 16. So how can I make that happen? Negative, negative. Is this finished? No. What's it need to look like? X minus 8 to the second power. Perfect. Okay, you guys got 6 to do today. They're not like drastically hard or anything. Go through, get them done, and then